Hi, this is the Chapter 2 summary for The Disappearing Spoon by Sam Keene. The title of the chapter is Near Twins and Black Sheep, The Genealogy of Elements. Chapter 2 begins by talking about the longest word ever, which appeared in a 1964 reference source for chemists. The word describes the tobacco mosaic virus, the first virus ever discovered in 1892. In this word, uncommon letters like Y and L appeared 183 and 255 times. Carbon is considered the sixth and most versatile element on the periodic table. It's the backbone of amino acids which form proteins, like the one that this long word describes. The rule to catalog amino acids is to change the -ine suffix to YL. For example, serine would be seryl and isoleucine would be isoleucyl. The chapter then goes on to talk about the octet rule, which describes an element's need to fill its outer energy level with 8 electrons. Since carbon still needs 4 electrons in its outer shell, which are harder to find, it will latch onto practically anything in order to fill it. Because of this, carbon can form steady and stable bonds with up to 4 other atoms and build complex chains and webs. Keene provides an analogy from genealogy to show how carbon has more in common with silicon, the element below it, than boron and nitrogen, the elements next to it. Both elements are in the same predicament of needing 4 more electrons for their outer shell, which also gives silicon flexibility even though it is not able to accomplish things that carbon can. The largest non-technical word in the Oxford Dictionary, which describes a disease, can be shortened to P45. Now, whether the disease is an actual disease is a question since it is a variant of another lung condition, P16. P45 is caused by people inhaling fine volcanic silica. Even though some people are enthusiastic about silicon-based life, the author gave an example of why this would not be possible since gas exchange would not be possible like it is with carbon since silicon dioxide is a solid and cannot fit its electrons into small places for double bonds. Even though silicon-based life is improbable, the author does point out that silicon has survived by preying parasitically on the element below it. Germanium is under silicon, followed by tin, and then lead. This is an example of how even though one element may resemble the one below it, it will still have small mutations. The black sheep of column 14 is known as germanium, which is considered a sorry, no-luck element. On the other hand, silicon is used in computers, microchips, cars, calculators, and semiconductors. The author then goes on to talk about an incident that could have changed the fate of germanium today. Back then, William Shockley was attempting to build a silicon amplifier as a replacement to vacuum tubes in mainframe computers. Engineers hated these vacuum tubes because they were cumbersome, fragile, and would overheat. After not being able to succeed after 2 years, Shockley passed on the task to John Bardeen and Walter Brattain. They succeeded by using germanium to build the world's first solid-state amplifier in December 1947, the transistor. Even though Shockley wasn't even in the country during this new invention, he ended up taking credit for the creation and tried to develop a better version of the semiconductor on his own. Bardeen ended up quitting and was so disgusted that he stopped semiconductor research. After Gordon Thiel demonstrated a silicon transistor at a conference, germanium was done. Silicon was cheaper, less temperamental, and didn't stall. Bardeen, Brattain, and Shockley ended up winning the Nobel Prize in 1956 for the germanium semiconductor. In 1958, Jack Kilby was hired by Texas Instruments to help them solve a problem known as the tyranny of numbers. Since computers needed a lot of silicon transistors in their circuits, TI had mainly women solder all the silicon parts together. But if one of the wires in the circuit broke, the whole circuit stopped working. Engineers couldn't find a way around this tedious process, and Kilby came up with the idea to carve everything needed from one block of semiconductor, instead of trying to carve all the pieces separately and put them together. All this also led to the first real computer chip. Kilby never received full credit, but his germanium model wasn't continued since silicon was much cheaper and more available. The chapter concludes with the author pointing out that most elements and scientists who discovered them are undeservedly anonymous.